As part of the Fruit project, we've now provisioned an AWS Lambda for the Fruit project API scraper and also an AWS step function state machine. Both of these have been provisioned as part of a feature deployment in the AWS Dev account for the Fruit project. Here we can see an overview for steps in a state machine. When the Fruityvice API is targeted, transformed records are uploaded to a Fruit DynamoDB table. When the Cocktail TB is targeted, transformed records are uploaded to the Cocktail Recipes table. When the Meal DB is targeted, transformed records are uploaded to the Food Recipes table. The AWS Lambda executions take place in succession as to help avoid service limits in relation to uploading records to AWS DynamoDB. With regard to deployment, we've used the Serverless framework, where the state machine forms part of an AWS CloudFormation stack. Now, before we execute our state machine in AWS, let's look at how the state machine is defined in the serverless.yaml file in the Fruit project API scraper repo. At the top of the file, target APIs are defined, and we also have the serverless step functions plugin listed so that a serverless step function state machine can actually be defined in a serverless.yaml file. So I'm going to scroll down to that, and this is about 50 lines or so, and that might seem a bit overwhelming, but actually it's really simple. So basically there is an update for a fruit table, a cocktail table, and then a food table, and those correspond to tables in DynamoDB. Each update here, we are using the same function, so our AWS Lambda provisioned for the Fruit project API scraper, and we pass a payload at each of these points, okay, for each update, and in turn we define each of the different target APIs. Okay, and if all those updates succeed, we will encounter this status: scraping successful. If there's any failure along the line, then the scraping process is reported as failed. Okay, so now we've looked at that, let's have a look at the state machine. From here, we can look at the definition, and this corresponds to what was in that serverless.yaml. I can actually go and edit this, and the UI is a nice little surprise, look. So let's go and look at this code. And what's going to happen is we will see the state machine first do its fruit table update, then it's going to do the cocktail table update, then the food table update, then it will reach scraping successful, and then we've got a bit of error handling in here. So if any of those fail, we'll go to scraping failed. So I'm going to simulate a failure because I think that would be interesting for you. I am going to take DB off at the end of there, So before I press execute, let me recap from the tutorial what the AWS Lambda for the web scraper actually does. Based on the payload, it goes and fetches a parameter from the AWS SSM parameter store, which in my case is actually based on this app and this source API name. Okay, and then if that is successful, the program will then proceed to scrape the target API. Okay, and then after that, there's logic to transform the scraped records, and then those are uploaded to a table in DynamoDB. Now I've done this change, let's see how this executes. Okay, here we can see the fruit table update was successful, and as expected, the cocktail DB update failed. I can expand the cause, which confirms that status scraping failed. Then here we can look at the log group as we had the error which was caught. I'll just click on the log here. Okay, we're in the logs. So we can see that there were 2 successful batch uploads to DynamoDB for transform records for Fruity Vice. As a reminder, with the cocktail DB, we edited the source API name which relates to it so that it's just been listed as the cocktail. And here in the error logs in CloudWatch, we can see that a value error is being raised because the source API name cannot be found. In the Fruit Project API scraper repo, we can navigate to a config file. In this API mapping config file, we can see a list of API names which are supported for the scraper application. So we can see the cocktail DB is supported, and this has to include DB at the end in order for that to be valid. Let's revisit the state machine in the AWS file and revert the change we made for the source API name for the cocktail DB update. I will now save the state machine and then execute this again. Great. It looks like all the tables updated successfully. Now we should cross-reference the execution time for the state machine with the timestamps for records uploaded to tables in DynamoDB. Looking at the start and end times, it looks like we should be looking for 1814 for the 2nd of September as our expected timestamp. Let's check records for tables in DynamoDB. First, I'll check the fruits table. I'll click on Explore Table Items for fruit. Here I can see that the timestamp is as expected. Now I will select cocktail recipes. I'll click here to get the timestamp. I'll copy this by clicking Control F, I can bring this up, and I will paste that timestamp here so I can get good visibility on it. This looks good to me. It's consistent with the timestamp that we expect. Now I'll look at food recipes, the final table. Again, I'll expand the view. I'll copy that timestamp again. And I paste the timestamp here, and that seems to be consistent with what we're expecting. In summary for this video, we've tested the AWS Step Function state machine for the Fruit project, which chains executions of a Lambda for a web scraper application. We've proven that executing a state machine leads to uploading transformed records in turn to tables in AWS DynamoDB.